Dear students, welcome back to this class. In this class, we will study history of unmanned aircraft because this course is all about the design of both manned aircraft and unmanned aircraft. So, in last class we have seen the history of manned aircraft. So, here we will see the history of unmanned aircraft or unmanned aerial vehicle. You can see the first UAV is built in 1783 and the use of military use was in 1849 and the application of aerial photograph has been done in 1858 and first camera drone is built on 1896 like that you can see, and in 2010 major companies start drone production, and nowadays in India only there is a lot of startup who is building the UAV from the scratch. So it is like a complete made in India project starting from design, development, testing and all, and while manufacturing all the components is made by India only, starting from material to the flight control system, okay, including the sensor and all. So what is unmanned air vehicle? Okay, so see the name itself implies that there will be no man sitting inside the cockpit, right? So it will be remotely piloted, remotely controlled drone. So you can control from the ground stage. So unmanned air vehicle is commonly known as a drone. So there is a little difference between unmanned air vehicle in a drone. If you talk about the more intelligence, then you will call as a drone. You will call as a unmanned air vehicle. So there is some small differences there between drone and unmanned air vehicle. As I said, it will operate without any human pilot. So it can be both fixed wing and rotary wing. For example, like here you can see rotary wing is kind of the hexacopter. You can see there is a 6 rotor has been placed, which the purpose is to lift this payload and deliver to the desired location. But this can be the fixed wing also or hybrid combination also, which is currently we are seeing, right? So this will be the application of the UAV. You can see the application can be the agriculture, the application can be the payload in medical emergency also. You can use the drone if you want to deliver some medicine or some kind of injection from one place to another place. Okay, and the doctor will sit inside the hospital only, and he will guide what to do, what to not. Okay, so that can be used, and for of course military purpose also can be used for hitting one particular target, okay, or or just protecting the borders. There are many application of drone is there. So the history you can see in this picture also. In the beginning of this era in 1849, when the Austria attacks using the unmanned balloons, but since it is a very lightweight, very sensitive to the wind, so some balloons is successfully hit the target and rest of them have blown the course due to the sudden change in wind direction. And now the first quad rotor you can see here, 4 rotor is there, right? There is a small quad rotor has been built and it is only attain the height approximately 0.6 meter. Okay, this is called the first quad rotor built in 1907, and in this quad rotor the structure is found not so steady, so a manpower required to keep the structure steady. Okay, and if you talk about the World War, then the Russian protector aerial target were developed for the World War won by the British engineer, and this is a actually military drone, and it is a radio controlled aircraft. And the Vietnam War and beyond, if you talk about, then you can see the drone with the camera and which is launched using the some kind of catapult mechanism. In a modern days, you can see lot of UAV with a very powerful maneuvering capability and intelligence. You can see, for example, you can consider as a predator drone. Currently, the US Army is using this drone. And if you talk about the classification of unmanned air vehicle, then you can talk based on the what is the size of UAV, what the weight class, the mission requirement also the classification can be made, and what will be the principal operation that also Based on this you can classify. You can see this class. The class is micro, mini, very small, small, medium, large, tactical, male is medium altitude long endurance UAV, and hail is high altitude long endurance UAV. So clearly you can see based on altitude and endurance the classification can be made. And you can see in a micro case the mass is less than 90 gram or 0.2 lb, like that you can see based on the mass also you can categorize the UAV based on the size also, and the range and operating altitude and range, and of course the endurance. Based on endurance you can also categorize. So micro and mini will always have the endurance less than 1, and you can see in hail aircraft the operating altitude is 50,000 feet to 70,000 feet. That means 15 kilometer to 21 kilometer operating altitude. This UAV can cover 40,000 kilometer range, and endurance is round the clock, more than round the clock, 30 to 50 hours endurance it is can get. And this is male UAV, so the altitude is a little less. For example, like it can fly from 15,000 feet to 30,000 feet, and this also can cover the endurance approximately 20 to 40 hour endurance. There is a lot of classes there, so we will take one example at least to show how this kind of UAV it looked like based on its geometry and based on its performance. Okay, and you can see, so you just have a little feel for the size also. This is less than 0.1 meters. See, you can imagine how small it is. Okay, you can see this is this comes under the both micro and micro UAV you can say. So this you can see the endurance is less than 50 minutes, right? And weight is how much? Weight is 1.3 kg. Okay, so if you go back to the previous slide, endurance is less than 1 and weight is, so in which class it will belong to? This will belong to mini and very small, in middle of that, right? And based on endurance you can classify as a mini, because endurance is less than 1. Endurance is less than 1, right? Less than 1, 15 minutes. And this type of UAV actually you can hand launch also, because weight is very less. As long as weight is less than 5 kg you can easily hand launch. Okay, and if you design some kind of this kind of UAV, then you will be having stall speed approximately 6 meters per second, 7 meter per second. So easily you can do with the hand launch. Okay, and the purpose is just for a surveillance. You put one camera which is approximately the 20 percentage of the total weight, or 10 to 20% of the weight, total weight, and not so much sensor is required here, because all of weight is only 1.3 kg, so you cannot put lot of sensor. You can put max to max camera or 1 2 more sensors. In a small class you can see here the gross weight is approximately 4 kg, and this is a maximum speed is around 50 knots. 50 knots is approximately 27 meter per second. It is a maximum speed, and again it can the service ceiling is around 3.4 kilometer, 11,000 feet, and endurance is 1.5. Okay, and since weight is less than 5 kg you can also do the hand launch. Okay, and if you consider the small UAV I'm talking about, because based on the weight class you can see it is weight is around 36 kg, and it is a catapult launch. So here the cruise speed is 125, which is roughly approximately equal to 34.7 meter per second, and endurance is about 2 hours. Okay, I will tell you the in detail, like what is the meaning by wing loading, what kind of area is required in order to lift the vehicle. Okay, and if we talk about the tactical UAV, so tactical UAV endurance is about 12 to 14 hours, and the maximum operating altitude is 16,000 feet. Okay, and it can covers the 200 kilometer range, and its speed is around 41 meter per second is cruise speed, and weight is around 265 kg. So based on weight class, you cannot say this is a tactical UAV, and based on the endurance and based on the what kind of mission it will perform, based on that you can say this is a tactical UAV. And this is a medium altitude long endurance UAV. You can see this long endurance means of course you will having a endurance more than at least round the clock, right? You can see the endurance is approximately 27 hours, and it can operate to 50,000 feet, and it can carry the payload approximately 386 kg, and the maximum gross takeoff weight is 4,763. So what it is a payload ratio, you can see 386 4763. So it is around 8 percentage payload is there. So by this seeing this number, actually you can have a feel for a like this kind of UAV will have a this kind of endurance, this type of wing loading and payload you will find generally from 5% to 30 percentage. So by seeing the data only, you can see okay, this kind of UAV will fly at this speed with this wing loading. Okay, so if you are, for example, in the future if you will design or your own UAV, then from this all published data you can actually verify whether you are going in that direction or not. Okay, because this number will tell you, these number are the history after the successful flight test, this number is listed, so you can verify in your design. Okay, so history is always important to know. High altitude, if we take high altitude long endurance UAV, then you can see uh, now the ceiling is 60,000 feet. Okay, it can fly the 60,000 feet, and endurance is more than 30 hours. It is a 34 hours endurance, and it can cover 20,530 kilometers. Okay, so it can go to US, and then it can come back also. Okay, so that kind of range it has. And wing span, you can see 39.8 meters, so long, right? 40-meter wingspan, so you can have a feel for such this much huge span this kind of UAV has. Okay. The weight is approximately 14,628 kg. So you can see that this weight is very much greater than compared to the many manned aircraft. For example, India's manned aircraft Hansa 3 aircraft, which weight is 750 kg. It can carry two people with one pilot and one crew, you can say, or passenger. And Cessna, the weight of this UAV is more than the Cessna weight also. Okay, which can carry the 4 to 6 people. Okay, this also some kind of you can say long endurance UAV only, hail UAV only, where the maximum takeoff weight is 6 to 72 kg, and speed is 34 to 40 kilometer per hour. Now you can see this aircraft. This is a fully solar powered aircraft. So this can fly 20 more than 24 hours, and you can see the weight is around 272 kg. So the solar panel is installed on the wing. So in the daytime it will charge. Okay, in night time that this can be used. Even in the daytime also this the energy can be used. And nowadays, have you seen that there is a hybrid type of configuration what is going on, where you will lift the vehicle vertically up, and then you do the forward transition, and you make the flight forward flight, and then with the backward transition you will land there. So this way you will not require runway, long runway. You can immediately start where you are. Okay, immediately take off where you are. So this rotor which is used to lift the vehicle vertically and land the vehicle vertically, and this wing will like act as a forward flight. This will provide the lift in forward flight. Okay, similarly to the conventional aircraft. So it is basically the idea comes from the helicopter, both helicopter and fixed wing aircraft. Helicopter has a own advantages, and fixed wing has a own advantages. So the idea is to combine these two concepts and build something novel configuration. So this kind of UAV you can see, and you can see duct fan VTOL. There are just so many, but I have listed some. Okay, this can also fly approximately 50 minutes. Okay, these are the some another drone is made for uh, surveillance reconnaissance. Okay, it's a business drone. So this is a UAV. It is also hand launch, and the weight is, if I remember, is less than 2 kg only. So whatever so far I have given you the UAV. Actually, I have taken the data from important data, and some data is not, we don't know. So we will have some kind of idea ki, from this data you can calculate the another data. So almost all kind of UAV I have simulated, and whatever the endurance they have listed here, and it's roughly matching. So that means it is good to have a take the data from all the UAV and you simulate yourself and check. It will be very, you will get very nice experience to see. So in this also, this type of UAV also I have simulated, and I got the exactly what is listed here. Okay. Even that weight class also, where the weight is around 14,000 kilogram and the endurance was more than 30 hours. That kind of UAV also I have simulated. Okay. You can see, but we have to, we should not forget that India is also has built some very good UAVs, and now India is growing rapidly in unmanned aircraft area. So this is a Nishant UAV which is weight around 380 kg or something. If I remember correctly, 383 kg, and this is the MQYC UAV. So I request you to go back and see this kind of UAV how they have performed, because I have listed so many UAV, right? Mini, small, medium, large, hail, male. So I have listed this kind of UAV also. You can see this picture. You do the literature review and found out how this UAV will do. Like I have shown already some of the examples. So you also do some literature review on this. Okay. And there are also in this UAV you can see that you will not see any tail, right? So you have, but you have later I will tell you how to design this. So this is a very sweep back, right? Okay. So when I will teach you the aircraft sizing, tail design part and all, then I will tell you how to size this flying wing, because you will see CG should be ahead of the aerodynamic center. But here you can see, you can have a feel for that what kind of UAV this is. This is a flying wing UAV, and it has a no tail. That is why it is called flying wing UAV, and it is basically used for combat purposes. Okay. And this is DRDO Rustam. The weight class is approximately, initially I think it was designed for a 18,000 1,800 kg, and then it is crossing more than 2,000 or 2,200, and it is used for a surveillance mission. It is also known as a tapas, and it is twin wing configuration. You can see if the one engine fails, then it can safely land on the under engine. So it is very good UAV designed by the DRDO, and there are many startups in India. They are designing very good UAVs for different purposes, agriculture purposes, military purposes. Okay, surveillance, payload delivery, medical purposes. So there is so many UAV has been designed, and India is, I must say this word, India is growing rapidly in the unmanned aircraft design, and in future we will see the UAV weight class which is more than 20,000 kg kind of weight class we can see, hoping to see in the future. Okay, so this is all about the unmanned aircraft history, and because it is important to know the history, and this all course is about both manned and unmanned aircraft. So manned and unmanned aircraft history I have explained to you. With this motivation, we will start designing our manned and unmanned aircraft from the next class. Thank you so much.